All right, so I think we are live now. Looks great, and we already have a few viewers. Would love to know where are you joining in from. A very quick introduction about myself. So I'm Shivai. I'm a developer advocate here at Couchbase, and I'm personally super excited about today's live stream because, of course, as we know that vector search, retrieval augmented generation are things that are super popular, but these days we are really seeing a complete revolution with the advent of AI agents. And today's session will be mostly focusing on what exactly are AI agents, but at the same time, how can companies adopt them for production? Because even today, if you look at the stage where companies are with respect to adoption, most companies are either evaluating how AI agents can be beneficial for them, or they're kind of trying to figure out that how can they productionize these agents. Because of course a lot of companies are trying their hands on with whether it's your LLMs, generative AI, and AI agents for the first time, right? So today's session will be kind of a masterclass on what are the building blocks for an AI agent, and then we'll proceed to also talk about what are the different building blocks, how what it takes to actually bring your AI agent into production, and then we have some cool demos that we have planned for all of you today. So with me today, I'm really happy to bring up Dylan, who is one of the senior product marketing managers for Nebius AI Studio. And I'll just quickly also bring him on stage, who has agreed us to join us for this webinar. First of all, again, a huge welcome, Dylan. Thank you so much for taking out the time. Do you mind giving a very quick introduction about yourself and what you do at Nebius AI Studio?
Yeah, thank you very much for having me, Shivay, and for this perfect intro. So, yeah, as I said, I'm Dylan. I lead the product marketing for Nebius AI Studio, which is part of Nebius Group. So we own and operate data centers across the world, and we're mainly what could be considered neo cloud, so providing GPUs to people that look to train AI models at scale. But Nebius AI Studio is a slightly different offering of Nebius. So basically, we're a high performance inference as a service platform. So the goal is to empower businesses to kind of leverage these new cutting edge open source AI models through a very simple and intuitive unified API. So basically, we built upon Nebius's robust cloud infrastructure, and then kind of built kind of the AI Studio seamlessly integrated into that, and allowing people to kind of integrate AI into workflows and scale that effortlessly. So thank you very much for having me, and looking forward to today's webinar.
Oh yeah, absolutely. Yeah. And I think people are already commenting on the comment section that they're excited for the session, so that's good to see. But yeah, I think like what you mentioned about LLMs and open source models, I think they are one of the most critical components of AI agents, as we will kind of discover. So Srini asked, by the way, this question about what exactly is Nebius AI. So you spoke about Nebius AI Studio, but what exactly is Nebius? Maybe like if you can answer that in a one or two lines.
Yeah, of course. So Nebius AI is kind of the parent company of Nebius AI Studio, and so as I was mentioning, the two ways to kind of like access AI right now is either through like inference, or actually people that are looking for GPUs for kind of higher scale training. So people that look to train or fine tune models at scale. So we've worked with people like Mistral, for example, that looks to kind of build their own model from scratch. Then you need a lot of computation power and GPUs to do so. And so that's what we provide these people, obviously with a layer of software on top of it to make it much easier. But basically, that's kind of what Nebius AI is.
Yeah, absolutely. And as I mentioned, that I think it's one of the most critical building blocks when it comes to building LLMs and using them for AI agents at scale, as we'll kind of learn from today's session. So I think without any further delay, let's kind of kick this off. So of course, this is kind of meant to be a more kind of open-ended discussion around what it takes to build AI agents in production. And of course, if the attendees, if you have any questions at any point in time, please do share them in the comment section, and we'll do our best to answer your queries that you might have during this entire session. And again, we'll be sharing our socials as well. So if you want to connect with myself or maybe with Dylan, we'll share this with you. So of course, the title today is mainly just kind of covering how you can build production-ready AI agents with the help of Couchbase and Nebius AI. So you'll kind of also understand that how you can leverage different tooling in order to build these agents by first, of course, like talking about what AI agents are. Just a quick housekeeping item: if you are interested in trying out and like building some of the demos that we'll be showing you today, you can sign up for the Capella free tier. So if you're not already aware that Couchbase Capella now has a perpetually free tier, so you can sign up by scanning this QR code. Of course, the video recording will be available to you after the session as well. So scan this and you can just register for free and get a perpetually free Capella for life, as long as Couch is there. And the other thing is you can also sign up for $100 worth of free inference credits for Nebius AI Studio. So as Dylan mentioned, that Nebius provides a lot of different open source large language models that you can use, so you don't have to self-host them on your own, and you can also actually fine-tune different AI models. So you can exclusively use this particular Couch Nebius, so you don't have to like send your private data to OpenAI or to Gemini. You can use these privately hosted open source models and not have to worry about data retention or being used for privacy. So yeah, I mean, highly recommend also scanning this if you want to get free $100 for inference. And you can, I think if I'm not mistaken, you can then use them on cloud.nebius.ai, right? Or is it? Yeah, perfect. So
No, studio
Studio.
studio.nebius.com.
Studio.nebius. Yeah, .com. Perfect. Yeah, so let's, I think Dylan would love to also pick your brains on what exactly are AI agents, right? Because we have seen that there has been such a huge rise in just the developer adoption and discussions within large enterprises as well about around the concept of AI adoption. And we are seeing that essentially every single product out there is releasing some or the other AI feature. In fact, I think like I was completely blown away by what Google I/O demonstrated with the advent of building agentic capabilities into Google search, where you just now add a Google search keyword as I want to buy or I want to purchase this particular item, and it will actually not just go to the product page via Google search results, but actually place an order for you if you have given it access to your credit card information. So we're seeing this huge disruption in the ecosystem where there are so many business processes that are getting automated with the help of with these LLMs and AI systems, and we are seeing such a rise in the interest. Right, I love to always talk about this particular use case. That if you look at how quickly products got more than 1 million plus users, ChatGPT was within a couple of weeks, whereas big companies like Instagram, it took them like 8-9 months to get to their first 1 or like 2 million users. So this the kind of adoption that we're seeing for AI is so huge, right? So maybe like if you can probably talk about what exactly are AI agents, would love to also like know from your side what you feel AI agents are, because we hear the term almost every single day. I think you're on mute right now.
Oh, sorry. Yeah, I think basically it's just a new way of approaching how LLMs kind of come and interact. So the way I see it is kind of a self-directed workflow that can both like read, decide, and act. And also, I think there's these two angles to it. Is like the fact that it's self-directed and the fact that it can use tools, memory, and structure outputs to do these things. So it's giving the LLM the ability to do more stuff and the ability to use more tools and external products to do that. So I think that's kind of the combination of both. And I think we've seen the ability to actually leverage more and more of these agentic frameworks really come to life with the rise of like these reasoning models in the last few months, because up to now the models were both less intelligent and didn't have the ability to reason. And so with the ability to reason and the ability to call these different tools, these models have unlocked a lot of skills and capability in terms of agentic frameworks. And so I think that now that real-time coordination has really been unlocked by most of the frontier models. So that's kind of the way I approach agents. To simplify it, I would say agents is basically AI plus tools plus memory plus goals, and it's the ability to go through that whole flow autonomously.
Yeah, and I think like as you very rightly mentioned that originally when these models like GPT 3.5, GPT 4 came into picture, I think what people do not understand is that they simply like the way that these transformer models work is that you give them some input text, get converted into tokens, and the idea is that this is predicting the next set of tokens, and most of them are text-based models. Now, of course, like some of them are also now getting into multimodal, but they still, the only thing that they do is generate these text, right? So of course if we want to give capabilities to these large language models so that they can connect to an external database, they can probably analyze some functions and give like analyze an API response and give you some response. They cannot do that on their own, so you need the capability to give them some set of external tools that they can use in order to make decisions apart from just writing text for you. And as you very rightly mentioned, that the idea is very simple, that agent is nothing but an orchestration of using these LLMs with some sort of a memory in order to accomplish business goals. So you can define that these are the set of tasks that it needs to perform, and it will, the LLM will kind of like act as that brain to choose, okay, like what sort of tool it should use in order to accomplish a particular task. So it has that reasoning capabilities, and it can perform tasks autonomously for you. So I mean, I think that's like one of the reasons why companies are particularly very excited, whether it's enhancing customer experience or maybe like reducing the cost and scaling. Like we'll probably discuss about more and more use cases that are involved with running agents in production. Um, but I wanted to kind of also like give this very quick example. So think of it in this way, like you are building a travel planner agent. So instead of like relying on maybe a travel agent for you and having to pay them, think of it in this way, that you are creating an automated travel assistant. So you can ask the agent that, hey, I'm looking to book this flight from a place A to B. Do you have any specific preferences? So the agent will, of course, ask you some additional questions that what are the dates you want to go there, and what are the things that you want to look out for, and then it can give you some suggestions for that. And now, because you could technically give these agents the capability of these external tools to also book the flight for you, and given the fact you have given it that enough information, it will go ahead and actually execute those particular tasks. And it can give you some follow-up responses for, let's say, booking your flight and giving you like probably an itinerary. And it can do all of these tasks in a structured manner and intelligently decide what to do next. And that's like one of the key aspects which I feel like is really powerful when it comes to building an agent. And to be honest, like the type of integrations that you can have are absolutely immense, right? Whether it's like connecting it with an external data source like Couchbase for being able to, or like a NoSQL data store where you're storing user preferences, or for a hotel data, it might be connecting again to an external API. If you're trying to get like weather information, it might be connecting to a time series based database. So there's so many different type of data sources that are available for it to use, and are available for it at its disposal, that you can truly like build whatever you want to build, right? And that's like one of the most important things about using agents in production, that you can connect it with whatever kind of data source you want, and it will be able to use that. Now of course, I know Dylan, you kind of spoke about memory as well, and like logging. So maybe can you share like what exactly is memory? So we understood that, okay, like LLMs are kind of like the brain behind an agent, but what exactly is the memory, and what is the significance of memory while building an agent?
I think it's mainly a question of context and providing the agent with significant context so that you can kind of go through numerous steps of the same query. So let's say you're actually looking to do one of the tasks you gave before, like buying a plane ticket. Let's say you give the agent that role in that kind of task, and it goes through the different steps of that task, but then gets interrupted or needs your input for whatever reason. So that's often a question of human in the loop here. And so in that case, memory actually kind of allows the model to kind of understand from previous conversation and chats. Of course, it depends like how far you want to go in terms of the memory, but usually, like for example, I recently built an example where it keeps the 5 last messages, so that's kind of enough to provide the agent with relevant context regarding the actual task it's supposed to work on. And so that's kind of the way it operates. So if you're to intervene and act as a human in the loop, the agent will be able to understand that the previous queries were regarding a specific topic, and then kind of allow it to be a bit more aware of the context on the task. So that's kind of the way memory operates in that case.
Yeah, and I think like this to probably piggyback on what you mentioned, it's also about personalization, right? So one of the things that I was really impressed by was the recent integration that ChatGPT had in their module, which is what they call as memories. And the idea is really just these memories. And what I saw was that with the recent release of memories, because it had taken context of all of the previous discussions and conversations that I had with ChatGPT, in the new conversations, the examples that it started to quote was it included my name, it included the company that I work for, and a lot of the different conversations that were related to like my personal life, or maybe like those were being brought in into the examples as well. So it was enriching its responses because of all of that prior information. So I feel like that's one of the really important aspects of building these personalized agents, right? Where you have full capability of these agents to become better over time, or not necessarily better, but become more personalized over time. Which is also like this term called as episodic memory, where your agent is given context of the previous conversations across multiple sessions, right? It's not just looking at the context of the current session where you can ask it questions related to some of the previous chat that you have had within the current session that you're running the agent, but you persist that conversation across multiple sessions. Which I think like that makes a lot of sense in order to make the agent more personalized for each and every single user, right? And as you mentioned, Dylan, like you were able to persist like the 5 last messages, so you can now expand this. And I think this is where you can use databases, and that's one of the reasons why databases are so important for proper functioning of these agents. And that is why you'll see that most of the traditional agent frameworks, whether you talk about Crew AI, Agno, maybe like Mastra, all of them have the capability to connect to either their inbuilt memory that could be stored in the cache, or you can connect with an external data source, whether it's SQL, NoSQL database, where you can store all of the previous conversations, and then you can refer back to them when you're building your entire application. So I think like that probably makes a lot of sense. I don't know, like Dylan would love to know about your thoughts around logging and telemetry, right? Because of course, it's not a new concept. Like we have been using telemetry, for a long time, and would love to know your thoughts about why telemetry is important, maybe for an agent.
I guess it's especially important given the fact that the agent is going to take decisions and operate by himself. It's even more important to kind of keep an eye on what decision have been made and why and how fast, and like, so there's a lot of factors to take into account just to make sure the agent is operating at the most efficient and clear level. So I think in that sense, what's really important is to have the ability to build integrations and have integrations with different tools. There's a wide range of tools out there that exist that can help you support that and kind of run your evaluations on your agent's performance and kind of go through different ways of optimizing it. So I think in that sense, that's why it's pretty important to kind of keep an eye, because as you showed and mentioned, there's a lot of different things involved here. It's like from the tooling to the prompting to the LLM you choose to the reasoning to the memory. And so being able to kind of keep track and orchestrate and look at the performance of each of these different elements in the workflow is really important. So yeah.
Absolutely. And as you very rightly mentioned, because if you think about a traditional software, you're looking mostly about things like, okay, what was the total amount of time that the API took to generate the response? or maybe you're looking at the health checks of your services, right? If you're having let's say a microservice architecture. I think like very similarly, as you very rightly mentioned, that because you're still dealing with LLMs, even though you have given it a lot more contexts, a lot of resources, all of these tools, but you're still having to deal with the non-deterministic nature of LLMs. So you never know that there might be scenarios where it might just not work because it just gives you a completely random response. So in order to like ensure that you're able to maintain a proper evaluation of whether the LLM is making the correct responses at all times is something that you want to probably track. And I think like most of the traditional open source agent frameworks today provide either an out of the box integration with open telemetry, or you can connect your own telemetry sync or source wherever you want to collect all of that data. So in fact, like within if you look at Couchbase, so we have this open source agentic framework that is basically built on top of LangGraph called as Agent Catalog. So an example of that would be that you can log all of your all of the responses and basically like store them inside of a collection within your database, so that you can go over them and understand how your agent has performed over time. So I think that's just like one example. So I think in a nutshell, if you kind of were to like synthesize what we have discussed so far, is this agent has all of these tools and the LLM at its disposal to help you perform business tasks in an automated fashion. And of course, what kind of tools it should use for a particular task or a particular use case being defined by the user, it will adopt based on the user's query and based on the prompt that we have given it. And then memory just allows it to become much more personalized, and then you add this logging to ensure that you are properly monitoring the performance of the agent at all times. So I think like those are kind of the building blocks for an agent, right? Dylan, if you would want to probably add anything to that, if you're missing something from like just the raw building blocks of what comprises an agent.
Yeah, so I think we covered quite a lot, but like just to add on top of what you mentioned, I guess model choice matters a lot here. So you want to be looking for models that are both fast, predictable, and that support complex reasoning. And so in that sense, it's really important to kind of choose the right model for your use case. So that's actually a good transition to the next part of the webinar. So yeah, as I was saying, you want to you're looking for efficient models, and you want predictable outputs, and you want them to be fast because there's a lot of steps in reasoning in an agentic framework. And so in that sense, we commonly use models like Llama, DeepSeek, or Qwen. The latest versions of Qwen are pretty good. What I would recommend anyone doing is go on different benchmarks. There's different benchmarks, both intelligence and the ability to call tools. And I think combining these two is kind of the best way to go at it and select the ideal model. I think many agent frameworks like LangChain or Cray are so like having built-in integrations for numerous reasons is very important. As we were mentioning, if you want to kind of evaluate your outcomes, or like use different frameworks to build these agents, or use different memory tools for memory, so you have to have some framework that's kind of integrated with all that. And so you want to have something that you could plug into the models without having or writing custom wrappers every time. And so in that sense, having built-in integrations with LangChain helps a lot. For example, or like LLM, Cray, N8N, Couchbase, of course, Helicon, Agno. So there's a lot of different tools in that ecosystem. You want to get structured outputs like JSON or function calls, which are like really easier to parse and integrate into tool chains, much easier than raw text. And so that's really, really important. Streaming is also supported when low latency is critical. So that's kind of pretty important too. Something I think is important, especially in agents, is since you're going to be sharing a lot of private and sensitive data, and you want it to go through all these different steps, you want to be able to be sure that there's no your data isn't leaking or going into like different providers that you don't trust or you don't have the clear vision on. And so in that sense, what we do at Nebius is allow anyone to kind of opt out of data retention. So inputs and outputs aren't stored by default, so you won't have to worry about your data going anywhere. You can just kind of use these models, open source models, on let's say you want to use European data centers, open source models, and no data retention, allowing you to be really, really comfortable with how the data is being processed across the stack. I think having open access is pretty important. So not being locked into a black box, being able to kind of change model at your will easily, really fast. That's pretty basic, but I think it's pretty important. Being able to be flexible on the deployment seems like also one of the best practices here. So using on-demand per token pricing, or using batch inference if it's needed in different cases, or like long-running agents. So I think all that is kind of very important too. And of course, if you're building agents that interact with images or UI, at Nebius, we support quite a few vision language models like QuenVL or like Lava or the latest Mistral. And those let agents reason over both text and visuals. And so the goal is kind of reduce friction, choosing good models that can integrate quickly and avoid infrastructure overhead. So you can really focus on your agent logic and not like platform maintenance. So being able to kind of have these different modalities and different agents is a really important building block here.
Yeah, and I think, of course, you mentioned about structured outputs. So that's probably one of the most critical aspects, because if you are not providing that kind of structured output, because if you think about it in this way, right, that you as a human is giving just a natural prompt in natural language, and now it's basically the LLM to deconstruct it and identify what are the key components that it needs to basically fetch from that particular user's query. And then it needs to basically fit it into the JSON for relevant tools that it can now actually go ahead and use, or basically instruct your agent application that, hey, you need to use this tool with these given inputs. So, like, to quote that example of the travel agent, where the user said that I want to travel from Paris to Amsterdam on these particular dates. So it is able to automatically parse that user's request and send that to that structured JSON. And now the output that the tool gives, that's also in JSON. And now it's basically how the agent or the LLM can now use that structured JSON response and automatically fetch data from it to give or stream the response back to your user. So while defining or while designing your application, I think like that's why it's so important that you properly take care of ensuring that yes, you have the JSON structure. And I think like while kind of discussing about this, I came across this really interesting uh, evolution of AI agents, because I guess like technically AI agents have been around for a while, and like would love to kind of like probably pick your brains here, Dylan, about this particular architecture. So if you look at the basic structure of how it all began, with the advent of OpenAI, with the Chat GPT, right? We had like what we had at number one, which was just input text on ChatGPT and it would give you an output. Then we came across the capability within ChatGPT to also upload PDFs. So it started to come with this inbuilt RAG kind of system where it would be able to answer questions related to that particular, related to those PDFs. And I guess like that's where then it started to have this kind of tool usage, and we also started to have things like the ability to connect it to external databases for RAG, being able to like generate. And we saw the multi-modal capabilities where it is not only accepting text, but it is accepting images, videos, or even audio files, right? And later on, we started to see like I guess like this is where we are in the current number five is where we're really right now, and would love to know if you also probably agree with this kind of an architecture where we basically we have that's the architecture that we have kind of discussed throughout today, which is the LLM now has capability of the tool usage. That means that it has multiple tools that it can use. It has capability of being able to accept multi-modal inputs, not just a text. So maybe you will have an agent architecture where the user uploads an image of their bill, and it automatically adds it to Splitwise. Or maybe like you have built a, uh, some kind of an application that can automatically ingest that bill for you, and it adds it to your company's management application where you're submitting your bills. And now you also have access to this memory, both short term and long term, or like what we discussed about the episodic. So would love to know about your thoughts around this architecture. And I guess there has been a lot of discussion around agent orchestration. So maybe like, what are your thoughts about agent orchestration, because that's something that we are probably moving towards.
Yeah, I think this kind of resumes it pretty well. We're going from very basic text-to-text chats to pretty complex architectures that kind of interact with all these different tools and memory. And so in that sense, I think, yeah, indeed, like as this shows, the architecture overall is getting more and more complex, hence even more need for like clearer evaluations and understanding of the different steps that go into it, but also having more and more reliable models that kind of replicate regular like interaction with these tools and don't have to kind of reinvent the wheel every time. And so in that sense, I think it's even more important to kind of both keep track of what you're doing, but also make sure that the models you're using and the tools you're using are really optimized for so. I think this shows it pretty well. You can't just go into some highly complex architecture like that without having a very clear and standardized approach. And so in that sense, I think that the challenges here are kind of similar to the ones we mentioned for the previous cases, but getting even more important as we progress and make these kind of architectures more complex. So yeah.
Because I think like the couple of things that we didn't probably touch upon, and would love to probably also know like how you handle that at Nebius with Nebius AI. So one is of course the ethics and regulatory compliance, right? Because companies are dealing with production grade workflows that involves directly interacting with customers. So maybe like they are interacting with their private data. How does securing your model basically works? Because ultimately, like even when you're pushing these particular AI agents into production, security is going to be one massive issue for companies, right? When they are dealing with AI agents. So maybe like would love to know from your thoughts around how you handle security with the LLM inference that you're doing with Nebius AI Studio, and like how companies can probably adopt a better security practice for even productionizing agents.
Yeah, I guess there's numerous things here. On a global company level, we're of course not only applying all the European standards like GDPR that kind of apply to us as a Dutch company, but also in the process of passing certifications like SOC 2 and HIPAA just to make sure we align with kind of the standards of security of the market. So that's kind of the first step here. Overall, I would say Nebius AI Studio is designed and optimized for production use cases. So not just prototyping. And in that sense, everything we have and we build is optimized for running real applications at scale. And so we're not just kind of a wrapper of a model. We're like a fully manageable, scalable backend built for having both predictable latency and cost. And that's really important. So it's not, in my sense, just about security. It's about security, latency, and cost. I guess these three aspects of it kind of come into play here. And so, as I was mentioning previously, there's a very big aspect to it, which is data retention. We've seen that a lot of customers and people and companies don't really like sending information over towards OpenAI because there's a lack of transparency at numerous levels. Like first, in the weights of the model, how the model is built, what data is trained on, but also how the data is used once you kind of interact with the different models on the platform. And so in that sense, I think we're addressing that with both leveraging the power of open source models and also applying a no data retention policy and allowing anyone to just come in and opt out of that. And so in that sense, prompts and outputs aren't stored. So if you're dealing with either regulated or internal data, you're covered on that side. So you're using open source models on data centers and in regulations and areas you can kind of understand and control, and you're also in control and full ownership of your prompts and your data. So I guess this is kind of a converging towards more safety, more ease of use, and more kind of ease of mind too, because you just know that you're not going to be exposing sensitive data, especially if you're using such complex architectures that you can see involve a ton of different external tools, and so in that sense, you have to be able to kind of know that each of these tools won't kind of leak your information towards bad actors. So in that sense, we're kind of really hands-on top of that.
Yeah, and as you mentioned, like being able to ensure that your data does not leave, that's like one of the things that even at Couchbase with the so this is some called as the couple AI services. The entire idea is that you can basically host the models themselves right next to your data, which means that they are in the same VPC network as the database. So this way, like you're not sending your data across to some private LLM like OpenAI, where you never know what might actually happen. And this also like helps with latency. But as you mentioned, like the entire premise of being able to like build these type of agentic solutions is the fact that yes, you want to ensure the privacy of of the models themselves and of the agents, and also ensure that at the same time you're basically implementing practices such as only fine-grained authorization. That means only certain set of users can actually access certain tools. So that's like one of the key aspects that will be built with this agent catalog, where on the tools, like let's say you have 20 different tools, but a certain set of users can only access 5 tools. So you get that fine-grained authorization on the tool selection, but also on the data, and then ensuring that you have proper things such as prompt injection. You're securing your application against those. But also it's about like thinking about as you look at this particular architecture, right? It's also about the we are seeing more and more architectural patterns when it comes to different types of agents. So we have like reactive agents, where the entire premise is that it's not just like simple agent, right? It's that how the agent can automatically think about what it's doing. It will make observations on top of it. Then you'll have a human in a loop, or maybe like another agent that can reflect back on its own response that it's generated, but not just directly give you a response directly, but it takes iterations, and over iterations it gives you the final action, right? So it thinks about it. It has the context aware reasoning. It then gives you tool driven decision making, but it then reflects upon it and has an internal feedback mechanism, and it finally gives you a human like thought process, like how a human will actually think about it. So that's like a reactive pattern. But the next one we have is an example would be a reflection pattern or a reflection agent, where the user sends an input query, the agent basically analyzes the request and plans an action. It executes that with the help of the available tools, but after the execution the agent evaluates in its own performance, and it reflects based on the insights, and then that informs the next reasoning phase, and you continue this in an iterative loop until you finally get a response back to the user. Or maybe another architecture could be a multi-agent collaboration, where you have multiple specialized agents that collaborate on tasks together. So agents basically communicate with the help of each other via communication protocols, and you basically combine the result of multiple agents with their individual contributions, and you can then basically like break down complex problems into separate collective tasks, and finally you basically like each and every agent autonomously adopts a specific role based on the feedback that it gets. So examples like Crew AI, that's like a great framework for orchestrating all of these multiple multi-agent frameworks. So we are also seeing different reactive patterns, different design patterns when it comes to like designing these particular agents. But yeah, in a nutshell, you're ensuring that security is an important aspect. How different agents are communicating with each other. You're having proper observability and monitoring for your agents, and then like it's not just a simple agent that does a tool call, but you add proper planning, tool usage, and then ensure that you have either a human in the loop or maybe like a self-learning loop that are applying to your agents, so that you can get much better architecture. So I guess that is a probably good segue for us to learn about one of the important aspects that Dylan, you covered, and maybe like you can spend a quick time on choosing like what type of LLM, because ultimately the entire idea is that all of these different LLMs that we have, there's so many different categories of LLMs, but ultimately the LLM boils down to like what LLM you end up choosing, because you have so many different categories, and ultimately like LLM acts as that fulcrum for the agent, right? So we'd love to know from you, and probably like you can share your screen and talk about what Nebius AI Studio is, and probably talk about like what type of LLMs. Would love to know from your perspective, like what LLM you should choose for what type of agent or use cases, right? So would love to hear from your side. So I'll remove
Yeah,
my.
most definitely.
Yeah.
Yeah, so as I was saying, I think there's a lot of different things that come into play when you're trying to select a good LLM for your agentic use case. And so it could be the intelligence, it could be the reasoning capabilities, it could be the ability to call tools, it could be whether or not you want the model to be able to analyze images, to answer to text, or to generate images, or to do a wide range of different things. For example, you could also be looking into using embedding models. So I think overall, the first starting point would be the use case. So what's your use case? And depending on that, also maybe you want some faster option, or maybe you're just looking for the base option, depending on how latency sensitive your use case is. So I think first off, it's really about asking yourself, what do I need? And what's the kind of ideal outcome from this agentic scenario, and this could kind of guide you towards picking a model that kind of works for your use case. I would recommend just starting off with the most recent models that came out, because they usually have the, like, if you pick the top AI labs in the world and just look at the latest models they release, they usually keep increasing in terms of intelligence, and then all the associated things like tool calling skills and abilities. And so in that sense, I think you're going to play it safe if you just pick one of the latest models that came out. What we have on Nebius AI Studio is a good playground to kind of be able to go through these different options and models we serve, and kind of be able to select the one that makes the most sense for your specific use case. So let's say I want to explore the latest version of DeepSeek, and maybe I want to compare that with Qwen 330B, which came out recently. So you can look, there's some information here. You can see it has JSON mode, reasoning code. It's good at code and math, and has 41K context, a bit smaller than DeepSeek R1, the latest version. So let's say you want to go to the playground, you can actually, I don't know why it's not open here, but basically you can go to the playground and compare these different models together, and submit the same prompts just to evaluate what different outcomes they provide. And so that's a good way of actually challenging these different models, and figuring out which one is the good one to use for your use case. I would say also it's good to kind of play with the different parameters, like looking at the bad, base, and fast option, for example, and kind of submitting any kind of prompt. So I don't know, code a biome snake. And so this is a good way of kind of starting out evaluating, once you have a use case, once you run a few tests, once you look at the speed, once you look at all these different factors that you want to leverage in your use case, then you can kind of pick the right model. So I think that's kind of the approach I would encourage anyone to have. So as you see here, for example, DeepSeek R1 thought for just 7 seconds and kind of went straight into doing the codes, whereas Qwen 330B is actually thinking for a lot more. So probably will take much more time to kind of achieve the same results, but at the same time, probably very interesting, because he's going through numerous iterations. So the outcome might be actually a bit more like precise and well formulated. So it's really a game of trying to figure out what you're looking for, and if you're looking for something really complex, if you're looking for something fast and efficient. And so in that case, I would kind of encourage people to go play around the playground, evaluate the different models, but also go and look at the different benchmarks that are out there. Speak with people, check out Reddit, see what people are saying about these different models, because it could be really any of the latest models, but it really depends on what you're trying to achieve and what your use case is. So I think that's kind of the ways to approach it. Also, let's say you can use, like, the good thing to keep into account is you can use different models in the same agenting workflow. So let's say you need a model for embeddings, you need a model for text and reasoning and chat, and so you could say, I'm going to use Qwen 3 for embeddings, I'm going to use DeepSeek R1 for text and chat, and let's say I need vision model, I can use like Mistral Small, which is really fast and efficient at kind of analyzing images. But then you can also imagine a workflow where you generate images, and so in that sense, you could like say, I'm going to use Flux and also in that workflow. So it's not just always about picking one model. You can kind of have these interact together. You can also imagine having models come in and kind of challenge the outcome from another model in the same agentic framework. So it's all about being creative, being thoughtful, and zooming out and kind of understanding the high level purpose of your agentic scenario. And once you kind of have a clear understanding of that, then you can kind of go at picking the right model for your use case.
Yeah. And I think, like, as you mentioned, that, for example, if you're doing a deep reasoning task, then maybe it makes sense to use a model that has a deep reasoning capability. So I think it all kicked off with the first ever chain of thought model that OpenAI brought up. And I guess, was it DeepSeek that had the first ever chain of thought, or was it OpenAI? One of them. And then everyone started to bring in new models that had that. So it basically, under the hood, it's using reinforcement learning to basically, like, reinforce itself on learning from the previous prompts and then do that. So a very similar architecture that we basically discussed about either the reactive agents or the reflection agents. These are the types of architectural patterns that you'll follow, and when you're building your agent, and even if, like, you have a multi-agent orchestration platform, you'll be using these capabilities to ensure that your agents are giving you an accurate result. So yeah, I mean, thanks for sharing that, Dylan. And maybe, like, I would love to quickly now also share my screen, maybe like my entire screen, and talk through like a couple of examples, that we built to kind of show you how your frameworks would look like. Now, of course, there are multiple ways in which you can leverage agentic frameworks. So I had like a couple of examples that I wanted to quickly showcase. So the first one is this Na10. So if you're not aware, so Na10 is this low code platform. It's really taking the world by storm right now. And in fact, like, a lot of companies are actually using Na10 right now. It's an open source project, more than 100,000 GitHub stars. So a lot of companies are actually using it for being able to, like, build agentic flows to solve business problems. So, like, let's say you want to build a platform or an agent that can take a YouTube video, generate shorts from it, or maybe, like, take transcript of a YouTube video and create automated messages that you want to send on social platforms like Reddit, Instagram, Twitter or X, Blue Sky. And you can design those workflows just by these GUI items, and they can run automatically. So in this example, I have a use case where I'm using Couchbase to build this AI travel agent where you will get recommendations for traveling. So, like, I had run this existing workflow where I was asking, okay, like, where can I go for a sightseeing vacation? And it gives me a response by saying that you can go to Eiffel Tower in Paris, because we have Dylan from Paris, so I wanted to make it Paris. So in this case, the flow is very simple. That as soon as the user gives a chat message, it orchestrates the agent here, and the user is asking a question, and here the simple agent is a semantic RAG agent, where based on the user's question, the question is sent as a tool. So we have a tool to perform vector search, where the user's question is converted into an embedding. In this case, I'm using like the Nebius embedding, and the user's question is done that, and then in your vector store you have all of your embeddings being stored. So you perform the vector search, and you get the most relevant set of records that are most closely matching to the user's given question, and you send that back to the LLM, and you fill that as context, and the LLM analyzes that context and gives a well structured response. So that's like the most basic example. So in this case, like, for instance, the model that I'm actually using in this case is the Qwen 3 model, because I have basically, like, so if you look at here, the API key, the base URL that I'm using is the base URL from Nebius, where we have the URL as the Nebius AI Studio, and then I've provided the API key. And now the model that I'm using here is the Qwen 3 model that can have the reasoning capabilities, but you can basically choose between the different models that are available. So this way, like, you can just use the base URL. Like, you can use an OpenAI compliant model, but just change the base URL and apply the settings which are for the API key and the base URL. And I use that, and then I have a separate workflow here that basically is a webhook that allows me to also ingest my documents into the database. and then I can just perform. So if I like probably execute this particular query again, maybe I can ask it another set of questions. So I just trigger this workflow where I ask it a question. So in this case, like sightseeing, and then I basically execute. So you can see that it goes step by step and performs that particular agentic task for you. So that's like one level of example where I've given it this question and it performs this retrieval rag tool operation as a tool, and it generates a response. But maybe like it could have taken this context and prepared like a dedicated itinerary for you as well, where it passed that context that okay, like Paris is a good destination. So maybe now you have another tool that is a 7-day planner or 7-day trip planner, and that 7-day trip planner agent now plans a real time 7-day trip for you based on another framework. Because I know we didn't talk about MCPs, but model context protocol is another protocol where any companies and its tools can basically be looped in. So a really good example that I always like to show to people is so my friend Arindam is building this awesome repository of different agents that you can take a look at, and he built this job finder agent, right? So if I just quickly show you the asset over here about the architecture. So what's basically happening here is that they have this Bright Data MCP server that can automatically like expose Bright Data APIs, and you can use them in your agent architecture. So you can basically fetch real-time LinkedIn data about a user, so you can scrape it, and now you can also then scrape your tools or like jobs from YC or maybe like some other place, and it can give you recommendations that based on your LinkedIn profile data you can get relevant information. Or you can also build a tool like the one that I built for myself. So I personally love to give talks, so I wanted to like generate a tool for me where like if I give it a prompt that hey, I want to generate a talk around like let's say VLLM and using it in Kubernetes. So I want to generate like a talk proposal where the idea is that this particular tool not only looks at all of the previous talks that have been given at this particular conference, but also looks at the latest things that are happening around us, around me, around this particular topic. So what's going on? Like what are the latest GitHub releases around VLLM and Kubernetes, or maybe like GPU inferencing on Kubernetes, right? And it does a couple of things. So one is that it uses an agent that does web scraping for you, and it parses the internet, x.com, linkedin.com, anything, and it gets all of that information for me. And it also performs a vector search on all of the previous talks to identify like what has been done even beforehand, so that I don't like submit the same topic again, which has already been submitted and has been presented at the conference. So now what it will do is that it will start to run this research agent that first scans the web for the latest trends. So in this case, I'm using basically what we call as something called as Google ADK, which is basically so this is the one which is a agent development kit from Google. So it allows you to create agents, and here you can see that I'm using the Nebius Quen 3 model for doing that. But I have a set of different tools. So I have a tool called Exa, which performs web search for me. And here I've given it that, okay, like just perform a general search. Then I have also some other tools like Tavily, which where I'm specifically asking it to go to x.com, reddit.com, and dev.to to find relevant information about the topic that I've asked it to search for. And then finally, like link up where you can go to Y Combinator, even GitHub to look at the latest information or code repositories about that particular topic. So in this case, it will look out for VLLM on GitHub. It will look out for Kubernetes on GitHub and find what's latest on those topics. So these are the tools. But then I define my agent. So in this case, I've defined all of the different agents. So in this case, it's the ADK research agent where I have specific agents that use specific tools, like the Exa agent will use the Exa tool, the Tavily agent will use the Tavily tool. And finally, I orchestrate all of them together where all of them run parallel. So each and one of these agents will run parallel. And then finally, I run a sequential agent that takes the outputs from all of these different parallel agents and synthesizes them into one single final result. And where do I end up using this research is basically I also now I'm using Couchbase to perform vector search to find relevant talks that have been given on that particular topic, so that ultimately I create this really well together proposal which combines the result of the historical context that I get from Couchbase of the previous talks that have been given on that particular topic and the real-time web analysis that has been done from my agent that's doing this web search, and it synthesizes all of this information together as one single agent and gives me a well-structured talk proposal that talks about the real-world use cases, builds upon the previous history that has been done, so previous talks that have been submitted on the same topic, and the real life or the real world things that are happening on that topic, and gives me a synthesized proposal. And then I've given it like particular prompts. So we didn't speak much about giving proper system prompts. So you can think of this as a really good system prompt on what exactly I want the agent to accomplish. And the end result is that you can see the real-time research that was done on this particular topic around VLLM on Kubernetes, and it gave me a summary of what's basically happening right now. So there's things like LLMD, which is a distributed inference on Kubernetes, and the enhancements that have happened over the last few months. And then it also gave me some talks about containers. You can see like how KMM and VLLM, all these different projects have been used to run AI inference on with the help of GPUs. So all of these talks were given. And finally, it synthesized, because I'm using the specific model here, which is the I guess the Quen model, if I'm not mistaken. Yeah. So I'm using the Quen 3 model that has a reasoning capability. So it reasons with all of this context in mind, and it finally puts together this title which says, okay, how you can optimize LLM inference on Kubernetes with the help of VLLM by taking the latest research about VLLM and building on top of the previous talks so that I don't repeat the same topic. And it gives me like this very well structured talk. So it tells me why this is unique, the key learning objectives. So that's like one example that I built an agent for my own use case. But you can truly like build whatever type of use cases you want. Maybe like an agent that does research for you and then helps you write a blog post. Or maybe like we have this example that we are about to release, which is like um, the idea could be that you want to build an agent that can automatically I'm not sure if I'll be able to log in here, but the idea is that your yeah, so like let's say you have a use case where you are having like production line operators where you want to build an AI assistant that can answer questions related to technical manuals that you have, or also answer real-time operational data about data that you're getting from a production line equipment. So all these different kind of use cases that you saw, right? Whether it's like a job searching agent, or maybe you're trying to build a deep researcher agent. So like trying to build a deep research, right? So you can do all of those. So there are so many tremendous amount of use cases that are out there. And so those are some of the things that I want to like quickly cover with some of these examples. Let me probably like just share that screen again with the slide deck. So just 1 second. But yeah, I mean, that is like the demo. But I know like we are running out of time. So maybe like Dylan, if you had probably any other thoughts about like what we just covered, maybe any final thoughts about, yeah, like this is what it takes to like build an agent and how agents are super powerful and super useful.
I think we covered all the main challenges associated with creating an agent. So I just want to underline that building an agent seems like a super optimized and simple way of like doing tasks, but it raises a whole bunch of new challenges and questions around these models and LLMs. And so you have to really approach this with a methodical and clear approach to kind of be able to make something that works. Because the goal, if you're looking to automatize frameworks and processes, then the real goal here is to make it as seamless and as efficient and as predictable as possible. And so to be able to achieve that, you really need to be able to kind of select the right models, select the right tools. And I think in that sense, we covered kind of the main topics and challenges here. So Well, thank you very much for kind of going through this. I'll be happy to answer any of the questions you might have. You can find us on Discord, on X, and you can also send me messages on LinkedIn if you want, at Dylan Bristow. So I'll be happy to answer and guide you through all these different steps. We have a team that's ready to be hands-on for anyone building enterprise use cases that want to leverage the power of these LLMs. Whether it's chat embeddings or like image or vision models, please feel free to reach out to us. We'd be happy to kind of explore different solutions that fit your use case best. So yeah, we're all open. Please reach out. Thank you again, Shivay, for putting all this together, and thank you for the Couchbase team to kind of help organize all this. So yeah, thank you very much.
Yeah, absolutely. And of course, I think there is one question.
Oh yeah.
So there was a question about 25 credit score rate. Yeah, let me probably bring up that particular slide again if people are interested.
It's actually, yeah, that's it. That's a mistake I made. It's actually $25 credits and not 100. So it's a $25 credit. Yeah, I didn't update the slide.
Yeah, yeah, I guess like.
But we're I've deleted the slide a bit late, but we're pretty flexible here. If you have use case that necessitates like that requires high amounts of tokens, we're willing to like provide a lot more and help you kind of onboard and help you figure out your use case. So yeah, any specific needs, please feel free to reach out. We can help a lot more.
And I think like one of the best things about LLMs is the fact that now the LLMs are becoming better and better, but they're also becoming cheaper and cheaper. So your average cost per 1 million tokens has considerably gone down ever since we had the first volcano effect that we saw with the DeepSeek R1 model that was originally launched, a few months back, and that really just saw the entire segment trying to reduce the costs. I mean, it's just sometimes it feels like bonkers at how much reduction net cost is, right, for a lot of these models. So I think like for companies who are building agentic use cases, now is the perfect time, because I think right now is a space where it's becoming very competitive. So there's this one question around, will it be possible to have Minimax's latest model on AI Studio?
Yes, we're actually working with the Minimax team as we speak. So we're looking to onboard this ASAP. I don't have a clear ETA, but I think it will be coming probably during this week or the next week. So yeah.
Yeah, some people are sharing out the great information session. So thank you so much to everyone who joined in. I know it's a working day, but still people took out the time. And again, like, thank you so much, Dylan, that you also took out the time on a working day for us. And we'll definitely follow up with everyone who joined in the chat. And of course, the recording of today's session will be live, and we'll update the description of the YouTube video with the slide deck and all of the different resources that we covered in today's session. But again, I think thank you everyone who came in, and thanks again, Dylan. We'll definitely stay in touch and we'll collaborate on more activities, and we'd love to have you again in a future session.
Thank you very much. Thank you everyone for joining. Have a great day.
Thank you.